Welcome to the tutorial. Today I'm going to show you how to train your own custom LoRA for WAN 2.1 1.3b model. I've streamlined the entire process, automated most of the setup, and made it easy for anyone to follow. Whether you're creating a style LoRA, an enhancer, or something completely unique, this guide will get you from start to finish, step by step. We'll be using RunPod to handle all the heavy lifting. It's fast, affordable, and saves you from using your own hardware. If you haven't created a RunPod account yet, go ahead and pause the video to set one up. Make sure to add credit to your account, then once you're ready, come back and we'll get started. Make sure to download all the necessary scripts for this tutorial if you haven't already. You'll find the Google Drive link in the description below. Alright, let's begin by logging into RunPod. Navigate to your pods and select Deploy Pod. Ensure that you're using the community cloud for this deployment. For VRAM, aim for 48 GB or more. In this case, I'll proceed with 48 GB. Next, we'll choose our GPU. Typically, we'd opt for the RTX A6000, but since it's currently unavailable, I'll use an alternative GPU for demonstration purposes. Now, it's important to select the correct template. Click to modify the template and search for better comfy UI. Be sure to choose the full version of the template, then select it. Before deploying, we'll adjust the storage, set the disk size to 100 GB, apply the changes, and you're ready to launch. Finally, click Deploy on Demand, and the pod will begin provisioning. Please note, you can choose to drag all the scripts that I shared via Google Drive into the workspace at once, or add them individually as needed. In this tutorial, I'll be importing them one at a time, just before each is required. Alright, when you launch your pod, it loads right up into VS Code. Drag the diffpipe WAN 2.1 Python script right over into the workspace, and then just go ahead and launch it in the console like this. This is going to install everything you need. It installs diffusion pipe, pulls all the necessary models for training, and also installs the models used in the native Comfy UI workflow. No manual setup. It's using the 1.3b model for text to image, and you'll see it's already downloading and setting up files. So at this point, everything's installed, both for diffusion pipe and Comfy models. Next, we're going to update the configuration files. Drag or upload the update config files Python script and run that in the console like this. That will update all your configs automatically. No need to mess with them manually. It sets some default settings for text to image, but you can tweak those later if you want. Now it's time to import your dataset. Just drag and drop your images and text files straight into the input folder. It'll upload everything. As you can see, I've got my image and .txt file. I'm not using a full prompt, just a trigger word in the .txt. I've noticed that if you're training on a specific image style or aesthetic, keeping it simple works best. Just using a trigger word gives you better results. When I tried using detailed prompts during training, it actually reduced the camera movement in the final outputs, and things felt more static. So for style-focused LoRAs, less is more. So with that being said, if you're using just a trigger word, make sure it's something unique and random, not a real word or something the base model already knows. If your trigger word is too common, the base model might try to interpret it on its own, without pulling from your LoRA, which can lead to weird or inconsistent results. A unique trigger word ensures the LoRA knows exactly when to activate and apply what it learned. Now, to start training, right-click on the diffusion pipe folder and go to Open an Integrated Terminal. This makes sure that we launch the code in the right location. Now, upload or drag over the TRAIN.NOW Python script into your workspace and launch it in the console like this. Hit Enter and we are good to go. Depending on how many images you are training on, the resolution, and GPU you're using, it could take anywhere from a few minutes to hours to train your LoRA. Alright, after some time training, you can see epochs in the output folder. As soon as an epoch is saved, you can start testing it. Keep in mind, the early epochs usually have less refined results. The model is still learning the core patterns and style. You might notice incomplete details, weaker style application, or inconsistencies in the output. That's totally normal. As training progresses, each epoch tends to improve in quality. It's a good idea to test a few different epochs to find the sweet spot where your LoRA looks its best. not too raw, not overtrained. In this tutorial, I trained on around 50 images at a 512 by 512 resolution. Now, let's take a look at how my Epoch 100 turned out. I'll be switching back to my own machine for this part since my GPU can handle running the WAN model smoothly. First, I'll generate an output without the LoRA. Then try it with the LoRA at a few different weight settings. Here's our result with no LoRA. Now let's try a weight of 0.5. Okay, we can already see a bit of a difference. It has a bit more of a vintage look, and she is looking at the camera this time, so that's good. Now let's try it with a weight of 1.0. A weight of 1 does really show off the LoRA, but since it was trained on AI images created by Flux, we are starting to get the Flux face. But let's move on and go even further and try weight of 1.2 just for fun. Okay, now let's compare them all side by side. As you can see, the LoRA made a pretty noticeable difference. It really gave the video that classic old-school vibe. Now all that's left is to add some VHS effects, sync up the lips with a voiceover, and you're good to go. Enjoy creating with your new LoRA, and feel free to reach out if you have any questions. Thanks for watching, and have an awesome day.